Hello everyone. Today we will be discussing pre-processing of spatial data sets. As you know that so far we have discussed what is GIS, different types of data which are used in GIS, how to handle them, and how to even raster data compression techniques. We have also discussed database management, especially for the GIS. Now in real sense the GIS starts from here. Basically once everything is prepared in our system, then we have to still go for analysis, but before that there are certain tasks which we have to do it, and therefore we put them in the pre-processing category, and processing or real analysis part will come little later. Now people have been dividing these operations in two major categories. One is the primary pre-processing steps, and then there are secondary. So we will see one by one all these steps, both primary and secondary, and see what are the processes which are involved, and most of these processes can be handled in any standard GIS software. So like primary functions, which are basic GIS functions, for example, we refer as GIS tools as well, depending on the software and terminology people use different. But the basic functions like area and distance measurements, if you are having polygon map, you would like to have area, distance, perimeter and other things would like to store within the database. These operations can be done very easily in GIS once your database is ready. Buffer generation, which is another important task, is required for certain types of applications and modeling. So which will be also doing, but buffer we will have a separate discussion on this. Then reclassification, that is also a part of pre-processing, that it requires a complete separate treatment. So we will be discussing that one also. Now let's look the secondary one. Secondary operations involves the advanced compound procedures using macro commands or modeling or expert system techniques. All these tools are also supported in GIS, and that we can also handle very well here, which is not very simple, but all these supports are available, so this can be also done on your GIS systems. Now let's go in detail about the pre-processing processes and processing or analysis one. So pre-processing involves the format conversion. This is a very standard task which we have to do on regular basis. What here format conversion means that sometimes we have to convert from analog to digital. This is one kind of format conversion. Sometimes we have to convert one vector data set into another vector data set. For example, the data set might be coming from DXF format, which is a AutoCAD format, and then you would like to import into GIS, maybe say ArcGIS, then you have to convert. Those tools sometimes are also available. Modern days even the softwares where you have developed the DXF file can also export to shape files which are suitable for ESRI products like ArcGIS, or some other formats can also be done here. Same with the image processing or image formats, like you might be having data in TIFF format, now you would like to handle in IMG format, which is again compatible with most of the GIS software, so you can convert. So the format conversion involves so many things. Same with your textual files as well. You may be having a simple table typed in a text mode. Now if there is a delimiter, you can use it, you can import in your database, and likewise you can handle. So format conversion is very much required in many steps it is required. And another one, data reduction and generalization. This pre-processing step is required as per depending on the target or the output scale of the map. So we will discuss little in details little later about the data reduction and generalization. Let's go first throw out this list of pre-processing steps. Error detection and editing, as I have already mentioned in previous lectures, that errors have to be handled very carefully, and after each and every step one has to check for errors. So once we find any error in our operations, we must immediately correct it, edit it, and then go for the next operation. Merging, we will also see in much details about merging. Merging, sometimes you are having two adjacent maps which you want to merge, or you merging in remote sensing domain, or even in GIS merging, maybe you are merging two data set, raster data sets, or two vector data sets. So that all merging we will discuss in little detail also later. And then edge matching is very much required, because a map projection, a map might be in a different projection, another adjacent map might be in another map projection. So you have to correct that one, and sometimes even if it cannot be done automatically, then user interactions are also required for this. Then reclassification, registration, rectification, registration, and georeferencing. That is also a common process between remote sensing, digital image processing, and GIS. Very important one, and we will be discussing in a separate lecture about georeferencing. Modern days we have started calling as georeferencing. That means your original images or data, sometimes when they are collected, they are in geometric domain, and which cannot be handled in GIS. So we have to bring them into geographic domain, and this process, converting from geometric to geographic, this is what the georeferencing process is. So we will be dealing this one in a separate lecture. Interpolation is another very important pre-processing step, because you might be having discrete data like point data or line data. You would like to create a continuous data. So for that, again, interpolation is required. So in future lectures we will be also discussing interpolations, different techniques of interpolations, their comparisons, and how to handle them, all those things. Then image and photo interpretation, because some lot of inputs are coming from satellite data or maybe some other sources, and therefore we require image interpretation, analysis of images, and maybe classification and other things. So that also we consider under the pre-processing category. So let's discuss in detail about data reduction and generalization. Data reduction, that doesn't mean that you delete the data. No. Data reduction means when suppose the output is required at a smaller scale, whereas you are having lot of detailed data. For example, say coastal line of India. Now you want to produce that map in a 5 million or 10 million scale, just would like to show the boundary of India. You don't want to show all details of the coastlines, and therefore you want to reduce the data, and that can be done under this category, data reduction and generalization. The examples are given here also, that some points or some internodes are removed in between, and then a new line has been created here. So that reduces the number of nodes and make your data more generalized form. So two examples are given here. One is this one. So you can make a smooth line as well, sort of best curve fit line, instead of all small kinks and bends which you can get rid of, and therefore you can generalize the data. This is very much required if you are changing the scale, or target scale is much smaller than your available data, and therefore before that we go for data generalization. Always remember that original data should not be disturbed, and whatever you do is you are going to create a new data set, and therefore there should not be any problem. Another example here is like thinning of coordinate thinning is here. So when small kinks, all these bands can be removed. So one node has been removed here, and therefore you get a almost very smooth line compared to what previous one. Similarly here in a real map example, here you can see that lot of details were there. In one step the generalization was done, and then lot of things have been removed, and then further smoothing has been done, and a very simple map has come. Because if this map I am going to print in a very small paper, then I do not need so many details, and if I am having so many details, the appearance of the map will also not be very nice. So, data generalization is very much required. One has to also remember, because when you are going for a smaller scale, at that time probably you are not very much concerned about the accuracy. So, generalization, as in the coastal area, this is how all details are not required. So, a very smooth line can be prepared here. As you can also see here that the scale was 500, 1 raised to 500, here 1 raised to 12,000, and therefore, when you are going for a smaller scale, you need not to have a lot of details there. Similar examples are also here. The scale is reducing here, and therefore, you do not need all those details, and everything is getting generalized here. Another example, size reduction. Sometimes you have to reduce the size, so that can also be done under this category of processes. There are a few more examples of similar, even for the line data, polygon data, point data, these things. Like here, point data, too many dense points were there. If I reduce this map, they will clutter. So, one has to get rid of certain points as shown here. Similarly, line data, if I go for this line data and if I reduce this, then these line might disappear. So, we have to thicken the line and keep at that scale. And generalization, as now we can realize, is a holistic process due to its subjective nature and the lack of well defined rules to guide decision making, which is necessary to compensate for visual problems. And during this challenging process, it is important to understand why to generalize, when to generalize, and how to generalize, in order to choose and apply the relevant operations to spatial objects. This is what the point which I have mentioned, that whenever you are going for large scale or detailed map or detailed boundary information to a smaller one, then you go for generalization. So, when to generalize, you can understand how to generalize. Tools are available, few things we have already discussed how to generalize, and where you will apply, this has to be decided by the user himself as per the requirements of your project, and these operators differ in terms of accuracy, quickness and complexity, because whenever you are going for generalization, of course you are compromising for the accuracy, and that is why I said that the original data should not be disturbed. Whatever you will create a generalized map has to be a new data set, and it is not very difficult either to do in any standard GIS setup. Similarly, error detections. Lot of error comes generally during your digitization processes. Earlier we used to have a digitizing tablet, a lot of errors used to come. Now we are having this so called the heads up digitization, in which we first scan a map through a scanner, and then we treat that map as a raster, and top of that whatever line or features are there, we digitize using your mouse cursor, and therefore during the digitization lot of errors can come. So, we will go one by one. There are certain names have also been given to different errors, because suppose you were supposed to digitize a straight line, but you left here and then you restarted here. So, a gap was there, it was not intended. So, this kind of error is called dangles. Then there might be again you wanted to digitize straight line, somehow you got another node and you came back little bit and gone downward. So, there is a shift as well. So, it is called switchbacks, and same there is a node which was developed, there might be a loop which has been developed, though intention was to have a straight line. Overshoots are there, and this should have started from here, but you over digitize it, undershoots you left and no link were developed, though everything was intended here, and these examples to have a straight line. Similarly, in case of polygon data, you might be having the problems of leaving a gap between two polygons, and here also a new set of polygons are there which are artifacts which were never intended. So, number of polygons in your database will be more as were not intended, and will give you problems in analysis. So, all these problems should be removed before you go for any further operations in GIS. So, if there is a overlap or gap like slivers, then it has to be removed. Another process which I have mentioned, I will go in detail, is a merging. Merging has got different meanings in GIS, and in merging, maybe merging two types of data sets. So, I am taking one example of merging a map for a certain purpose, which is the chain detection. We wanted to detect the changes which have happened between 1968 and 1998. So, in these roughly 30 years, we wanted to see what are the changes which has occurred to the Dal Lake. So, we scanned this topo sheet and treated as an image, as a raster, and you know any colored image is made from three colors. So, presently all are here. Then we will also see the details of against these two boxes which are marked here, and this is the satellite image of 1998, which is a infrared channel, because we wanted to see the changes which has occurred in the vegetation, especially within the body of the lake or the water. And when we merge these two, then we get a new product, and which is also having in the background your map of 1968 and the satellite image of 1998. 30 years time difference, and all these red colors are appearing here as the vegetation which has encroached between 1968 to 1998. So, this is also one type of merging which is possible in GIS softwares. If it is not, then we can also resort to some image processing softwares to achieve this, because then we can use this for a certain purpose. Here in this example, the purpose was to first to identify what has happened in those last 30 years and where the encroachment has been done by the growth of vegetation or by human settlements, which we will see here when we go for a larger one, and what remedial measures are required. So, exactly after such analysis, exactly you know where things have changed drastically, where the corrections are required. So, let us see the detailed one. This is the input map, this is the input satellite image having 30 years age difference, and this is the final product, which is showing that on this lake boundary, these are the areas which has been encroached by humans. Even the channels which had the connectivity with other lakes were also blocked by the extensive growth of vegetation all around here. And another in northern part, similar thing, again input map, input satellite image, as you can realize that this is the area which has been encroached by the vegetation. So, this is another merging technique. Merging techniques again for chain detection can be say in example earthquake induced landslide. So, this is pre-earthquake image, this is post-earthquake image. In previous example we have seen 30 years time difference. Here what we are seeing just 5 days time difference. So, in between on 29th March 99 the Chamoli earthquake came. So, we wanted to see that how which are the landslides which are induced by that earthquake event, and it is very easy, again almost the same way that you assign one color to this one, you assign red color to this one, and again because if we go for a pseudo color transformation, then two channels can be assigned this pre-earthquake image, one channel red channel can be assigned post-earthquake image, and you can create a product like this. And so here again all red areas are showing the changes between only 5 days. In the previous example changes were shown of 30 years, here only of 5 days, and in between the earthquake. So, we can attribute that all these landslides which have occurred are induced by that particular earthquake event. So, the confidence level becomes very high for in such analysis, and these tools can be exploited extensively in GIS, the merging one. Similarly, one more example is also there about the liquefaction phenomena, which is again a co-seismic phenomena. Again, similar technique has been applied for pre-earthquake image and post-earthquake image. That earthquake came on 26 January 2001, when we merged this image pre and post-earthquake and created a pseudo-color transformation. All the red areas are showing where the water bodies were appeared during and just after the earthquake, and after few days these disappeared, and that is why you are seeing all these red, and even you can see the clear channels which appeared having a fresh water body, and this phenomena is called liquefaction. Since this is beyond of scope of this lecture, so I am not going to detail about these phenomena, but what emphasis here is how to use your data sets, whatever is available in your system, to create new products which are very convincing. You will have high level of confidence and you can have very accurate results, like examples I have shown for Dal Lake, I have shown for Chamoli earthquake induced landslides, I have shown for Bhuj earthquake induced liquefaction phenomena. These are the way you can do it, like in this example. In merging techniques, one of the very standard image merging technique, that you can take a high resolution panchromatic data, you can take relatively low resolution multispectral data, you do the image to image registration, the topic which we will discuss later, and then you registered the pen, you use the registered pen data, you registered the FCC, and then what you need to do is a splitting of the image from RGB to IHS. IHS stands here, intensity, hue and saturation. Intensity image is not carried further, only hue and saturation images along with your registered pen image, which is carrying high resolution, high spatial resolution data, and you go for backward transformation from again IHS to RGB, and you go for a high resolution multicolor or multicolor image or a false color composite high resolution. So we started with the relatively high resolution but panchromatic single color or single band image, here relatively low resolution but colored image, and we end up with high resolution colored image. An example is shown here, that how this intensity, because you have to when you go inside this color space, then you can play with the different planes. Instead of projecting your things on RGB plane, one can project on IHS plane and so on. So this is the one cone inside of that one. And let me show you some examples of this merging of high resolution panchromatic image with the relatively low resolution of multispectral image. So this is pen image having resolution of 5.8 meter, and this is the corresponding image of list 3 having 23.5 meter, but this is colored, this is black and white, but it is having higher resolution, it is having color but relatively low resolution. So we through merging techniques you can exploit the best out of these two inputs images and then create a new product, and like this it has been created. So now you are having high resolution, same time colored image. So likewise you can generate lot of merged data which later on can be used for different kind of analysis and modeling purposes as well. These are the zoom parts of the that this is a colored image, input image, this is a black and white pen image but high spatial resolution, this is the output. As you can see, this is Delhi golf course. So here the vegetation details are there, here are the spatial details are there, both have been merged. There are slight changes in the colors which can be adjusted as well. Last topic in this one of pre-processing, there are other steps which we will discuss in separate lectures. So edge matching is, I have mentioned earlier that when you are having two adjacent maps and they are might be having even same projection or different projection. Sometimes the boundary will not match. So, they are here the line may not match from one map to another. So, some human interventions are required, and then whoever is doing that part can bring this data to here, and if there are some shifting is required, that need to be also done. Similarly for a straight line, similarly for polygons. So, edge matching is many times very much required, so that your data becomes seamless. Otherwise, it will create unnecessary artifacts and problems during your analysis. Similarly here also, that edge matching can be done. There are tools, example of ArcGIS is given, that you can shift this one and bring here, and then a perfect, because this white colored polygon was never intended, but because of sliver problem this problem came. So, it can be removed very easily from here. So, this brings the end of this presentation about the pre-processing of our data into GIS. Thank you very much.